Okay, hello everyone, and welcome, and thanks for watching. Today we're going to start normal distributions. This is day 10. We've already talked about it a little bit. We're just going to look at them a little closer. Our objective is just to understand where a data value lies in a normal distribution. So our essential question is, how can we use a normal distribution to explain where data values fall within a population? Now, again, a normal distribution, we've talked about it before. It shows data it varies randomly from the mean, from the average, and it displays in the form of a bell-shaped curve. That's what they call that curve. It's bell-shaped, okay? And normal distributions, they happen a lot in the real world. We can take a look at a couple here. We've rolled dice, right? We rolled 2 dice. Let me get to 2 dice. There. Let's just start rolling them. Can I just roll faster? Yeah. There we go. Let's just get them rolling for a while and see what happens. We'll look back at them at the end here, okay? So we got this Galton board. I think this thing's kind of cool, actually. We'll go ahead and start it. I can go a little faster here. There we go. All right, we're just going to get it going for a while, and we'll come back and take a look at it. Again, you always say that data is normally distributed when the mean, the median, and the mode are pretty much equal. It's symmetric about the center. So 50% of the values, or half the values, are less than the mean, and half of the values are greater than the mean, okay? Now, this is a very important graphic to understand. Because if the mean is right in the middle here, and it's normally distributed, one standard deviation away from the mean on either side is 34% of the data will fall within one standard deviation of the mean on either side. So that means 68%. 68% will fall within one standard deviation of the mean. All right? And within 2 standard deviations of the mean, these 2 right here, all this data, that's 95% of all the data values in a normal distribution. It's a very important concept to understand. Let's look at an example. Again, we kind of looked at this already. But if a data set has a mean of 75 and a standard deviation of 3.8, and it's normally distributed, what value is 3 standard deviations above the mean? We kind of looked at this. All right, you just take 75 and add 3.8 3 times. All right, we end up with 86.4. We've already looked at an example like that. But an example like this is a little different. They're asking for a percentage. All right, it's the same set of data, a mean of 75 and a standard deviation of 3.8. They're asking what percent of data is between 2 numbers, 67.4 and 82.6. Well, luckily, and again, all of these will be like that. As if we add 3.8 to 75 twice, and subtract 3.8 from 75 twice, we get the 2 numbers that we're talking about. 67.4 and 82.6. So those are within 2 standard deviations of the mean. And we know that 95% of the data falls within 2 standard deviations of the mean. Now, if you want to see a picture of this, it looks like this. Again, 75 is the mean, right in the middle. So 2 standard deviations up gives you the 82.6. And 2 standard deviations down gives you the 67.4. And again, 95% of the data. Again, we're talking about percentages now. We're going to be doing this here for a couple days. The percentage here is 95%. If you add up all four of those numbers, those four percentages, you get 95%. All right, what I want you to do now is go ahead and complete the puzzle piece. Again, there's no folders today. All right, just go to today's assignment folder. There's no purple or green folder. Then hoping that y'all can get in groups and make a nice poster to hang in the room. Something that looks like this, right here. With the percentages in there, a nice bell-shaped curve. Show what the mean is. Put your names on it. I will talk about that. Oh, now let's go back and take a look at our boards. Ooh! Here's the Galton board. It's pretty, see how it's pretty close to a normal distribution? It's pretty close. It's hard to get on the outside there. And what about our two dice rolling? Yep, it looks pretty normal. It's not perfect, guys, but it's pretty good. All right, the numbers in the middle will always, 7 will end up being, if we rolled millions of times. See, this is only about 500 rolls here. The 7 would be the highest. It's the highest right now, but you can see, as you can see, it's got some competition. All right, that's it, y'all. Thank you so much.